Among the myriad worlds in our solar system, Mars captivates our imagination like no other. Often referred to as the Red Planet, it stands as a testament to our relentless curiosity and our desire to explore the unknown. With its stunning landscapes, scarred canyons, towering volcanoes, and polar ice caps, Mars presents a compelling narrative of a planet that was once vibrant and dynamic. Today, we embark on a journey to unravel the enigma of Mars' habitability, exploring its ancient past, the current state of its environment, and the tantalizing possibilities that lie ahead for future human exploration and colonization. To truly understand the habitability of Mars, we must journey back in time to approximately 4 billion years ago. During this period, Mars was dramatically different from the arid landscape we see today. Scientific evidence indicates that Mars once boasted a thick atmosphere rich in nitrogen and carbon dioxide, along with vast oceans that may have covered a significant portion of its surface. Geological features, such as ancient river valleys, deltas, and lake beds, suggest that liquid water flowed freely across the surface, creating conditions suitable for life. This primeval environment raises tantalizing questions. Could microbial life have once thrived in these waters? What remnants of this ancient life might we still discover beneath the Martian surface? Fast forward to the present day, and Mars presents a stark and arid landscape, shaped by eons of climate change and geological processes. The planet's thin atmosphere, composed primarily of carbon dioxide, provides minimal protection against cosmic radiation and solar winds. With an average surface temperature of around -80 degrees Fahrenheit, Mars is a frigid world where conditions are inhospitable to life as we know it. Despite these challenges, recent discoveries have ignited a spark of hope within the scientific community. Evidence of subsurface lakes of liquid water, rich in salts, has been detected, suggesting that conditions for life may still exist beneath the surface. These findings challenge our assumptions and invite further exploration into the depths of Mars. Robotic missions have transformed our understanding of Mars, enabling us to gather invaluable data about its geology, climate, and potential for life. NASA's Perseverance rover, launched in 2020, is a cutting-edge explorer equipped with a suite of advanced scientific instruments designed to search for signs of ancient life. Its mission is multifaceted. It collects rock and soil samples, analyzes the planet's atmosphere, and conducts experiments to prepare for future human missions. Curiosity, another pioneering rover, has provided critical insights into Mars' past environments, confirming that it once possessed the essential ingredients for life. The results of these missions not only deepen our understanding of Mars, but also lay the groundwork for future exploration. Recent studies have unveiled a tantalizing prospect. Beneath Mars' surface lies a hidden network of saline aquifers where liquid water could persist despite the harsh conditions above. This discovery opens up exciting possibilities. If life ever existed on Mars, it may still be thriving in these protected environments, shielded from the planet's hostile surface. The potential for discovering microbial life, whether ancient or contemporary, is a driving force behind our exploration efforts. What might these organisms reveal about the evolution of life in the universe? The answers could reshape our understanding of life's resilience and adaptability. The question of habitability extends beyond the search for microbial life. It encompasses the feasibility of human colonization. Leading organizations like NASA and SpaceX are actively working on ambitious plans to send humans to Mars within the next decade. This monumental endeavor requires meticulous planning and innovative technologies to ensure the safety and success of human missions. To establish a permanent presence on Mars, we need sustainable habitats that can protect against radiation, extreme temperatures, and the planet's notorious dust storms. Envisioning the first human settlement on Mars evokes a sense of wonder and excitement. Imagine scientists, engineers, and explorers living and working on the Martian surface, conducting groundbreaking research and paving the way for future generations. One promising approach to overcoming the challenges of Martian colonization is in situ resource utilization, or ISRU. This strategy involves harnessing Martian materials to build habitats and support life. By extracting water from subsurface ice deposits and using the planet's regolith, its soil and dust, to create structures, future settlers could significantly reduce the logistical burden of transporting supplies from Earth. Advanced technologies, such as 3D printing, could allow us to fabricate essential tools and equipment using local materials, fostering a self-sustaining colony that thrives in the harsh Martian environment. This innovative approach not only supports human habitation, but also ensures that missions are more economically viable. However, the journey to Mars is not without its formidable challenges. The planet's thin atmosphere offers minimal protection from cosmic radiation, which poses significant health risks to astronauts. Prolonged exposure to radiation can lead to severe health issues, including cancer and other life-threatening conditions. Researchers are actively investigating various shielding techniques, including burying habitats beneath Martian soil or constructing underground facilities to safeguard human explorers. Additionally, Mars is known for its extreme weather conditions, including massive dust storms that can last for weeks and obscure sunlight. These storms complicate solar power generation, a critical resource for sustaining human operations on the planet. Understanding and mitigating these hazards will be crucial for the safety and success of future missions. Exploring Mars is not merely a national endeavor. It demands global collaboration. The challenges we face in reaching and colonizing Mars are immense, and international partnerships will be essential for pooling resources, expertise, and technology. Initiatives like NASA's Artemis program, which aims to return humans to the Moon, serve as critical stepping stones for future Mars missions. By sharing knowledge and working together, countries can tackle the complex challenges of human exploration and increase the likelihood of success. Collaboration among nations, scientists, and private companies will be the cornerstone of our efforts to explore and potentially inhabit the Red Planet. As we gaze into the future, the idea of terraforming Mars, transforming its environment to make it more Earth-like, invites us to ponder profound questions about our role as explorers and stewards of the cosmos. Concepts range from releasing greenhouse gases to warm the planet to introducing genetically engineered organisms that could produce oxygen. While these ideas remain largely theoretical, they underscore our desire to make Mars a viable home for humanity. The dream of terraforming raises ethical considerations as well, urging us to reflect on the implications of altering another world. How do we balance our aspirations with our responsibilities to protect the Martian environment? The habitability of Mars is a complex and evolving narrative, woven together by the threads of its rich geological history, the ongoing search for life, and our aspirations for human colonization. As we stand at the threshold of a new era of exploration, Mars beckons us to consider our place in the cosmos and our responsibilities as stewards of both our home planet and the worlds beyond. With determination, innovation, and collaboration, we may one day walk on the Martian surface, embarking on a new chapter of human existence exploration, and discovery. The journey is just beginning, and the future holds boundless possibilities.